So in this video, I'm going to talk about like how can you architect a modern video platform. So it is a kind of a technical blueprint for the browser native capture, direct CDN uploading, and an AI-driven playback using Net.js and a Mux. So Mux is a Mux is an API-driven software where it allows for the live content to be done. So if you can see an example, you have a browser native capture, you use your device or a camera, then you have a media stream API, and then the client side encoding, and then when you do an upload, it goes to the Mux upload API. You do a transcoding and optimization, then you have a 3D and edge distribution, and then your data analytics storage. Then you go for a AI-driven playback next to JS application. So this do the site rendering. You have a dynamic metadata injection and a listing, and then you have an AI enhanced feature. And it also has the AI anti-patterns and a bottleneck. And the stack components are neck.js, React, Mux Video, Tailwind, CSS, Versal. Data flow is like browser. Then you go to the CDN direct, and then you have a Mux processing, and then it goes to the Next.js Plays. Key metrics is low latency, high quality, scalable, developer friendly API. So what is the inherent complexity of the video engineering? The core problem is like the raw 500 MB video files break standard wave infrastructure. You have your encoding and codecs, raw file user diverse incompatible codecs, native browser PVX requires strict standardization, example web MP4. You have in streaming formats. The standard video tags force complete downloads before playback. Platform require HLS.m3 UART to chop video into 2 to 10-second chunks. Then you have adaptive bitrate, which is like a static file buffer on a poor network. Optimized platforms encode multiple simultaneously quality tiers, 180p, 720p, 360p for seamless switching. Then it goes for the global distribution where the massive video chunks demand hyperfast edge delivery worldwide to prevent latency and ensure instant start times. So what happens, you have a routine large file server relay versus direct upload. So user, then you have a next.js servers, and then you have a Mux CDN. So servers becomes a severe bottleneck, paying for the bad one twice, massive memory spikes during 500 MB plus upload. Direct upload production into a Next.js server, user request signed URL, then your grant temporary URL, it goes to the Mux CDN direct access transfer. Server never touches the massive video files, uploads utilize globally distributed edge network, highly secure, single use signed URL. So now onto the user client, you have the browser and the client interface. Accessing native browser media APIs, managing React for UI state, recording, stopping, uploading, rendering the MX video player component. It goes to the server actions next.js where you have a secure backend operations, safeguarding Mux token ID, Mux token secret, generating direct upload URLs, polling Mux API for asset processing status. Now it goes to the native browser media capture. You have a screen visual, get display media, config video true, audio false. You have a microphone audio, get user media, config echo cancellation and a sample rate. The stream manager, the merger, new media stream, video track, audio track, output chunk, media recorder API, format, WebM, codec, VFN, critical UI node. Live video preview must be set to muted to prevent a destructive audio feedback search. The direct upload sequence, the browser, the request, the browser calls server action, create upload URL upon click. It goes to the signature server user Mux node SDK to securely request a temporary signed upload URL. Then the hands-off happens, server passes the single-use secure URL back to the client environment. And then the transfer browser executes the put request, direct sending the WebM blob to global ingest server, requires course origin asterisk. Now, let's define the asset processing tier. Basic is lower cost for your rendition. Standard high-level streaming only. Verdict insufficient for the modern app requirements. The plus is annual standard MP4 generation for direct file download. Crucial unlocks Mux AI capability. Vista transaction summary. Note: if AI was run to basic tier, the API throw a terminal error. Premium is like a maximum quality. Redemption full 4K support. Right? Yeah. So what is the cloud processing pipeline looks like? You have a raw WebM file, then it goes for the transcoding and APR, converts raw WebM into multiple quality tiers and creates .m3 UART HLS playlist. You put the watermark injection overlay specified PNG URL at a designated opacity and screen position. Then you go for the audio transcription, routes audio track through OpenAI Whisper model to generate English subtitle. Then you have a playback ready ID. So the Next.js application utilizes a state's polar component pinging servers every 3 seconds to check if status is equal to ready and transcript track exists. So how adaptive bitrate streaming protects playback? You have a master file, you have a 1080 chunk, high bandwidth, you have a 720p chunk, medium bandwidth, then you have a 360p chunk, low bandwidth. So Mux Player client bandwidth monitor the mechanism. Infrastructure encodes video at a multiple quality level and chunks them into 2 to 10-second segments. Robot Mono, the player role, continuously monitors live internet speed, automatically switch to optimal chunk size midstream, ensuring zero buffering regardless of network volatility. The playback interface, player 1, player core, wrapped in a next.js client component stream type. On demand, you have a thumbwell architecture, each CDN generate poster images and hovers GIFs. Crucial next.js component must use unoptimized true with image.mux.com, whitelisted Mux servers, WebP, AVI neatly, double optimizing breaks rendering, accessibility out of the box, keyboard navigation and a focus indicator, screen reader support, automatic closed captions toggle with a whisper transcript. Automated metadata extraction via Mux API, whisper generated transcript, Mux AI in underlying LLM, configure tone professional. It generates in a key value pair, title, summary, the tags. Now, how do you secure with a JSON web token? So you are securing your playback with a JSON web token. So basically you do a policy shift, upload configuration changes from playback policy public to the sign. So you have the application, which is authorization, user request video server validates internal application authorization logging, example cookie session ownership. Then you are signing server generates a JWT sign with private Mux singing key. Then you have a payload structure, which is like a Mux play ID, the video playback, expiration time, public signing key ID. Then you have a playback authentication. The token is passed directly to the Mux player client component, authenticating the stream instantly. Now in the phase 1, so what is a complete modern video architecture looks like? In a phase 1, you're going to capture it's a browser media API in the form of WebP blob. In the second phase, you are going to ingest using a signed URL. Then you are directly putting the SCDN. In the phase 3, you are transcoding and a watermark with an ABR playlist. Then in the phase 4, you are having some intelligence by the whisper transfig and LLM JSON metadata generate. And then in the delivery, you are authenticating using the JWT, which is securing the player client. Now, how do you scale to production? So replace polling with a webhook, swaps the 3-second client-side status polling for the Mux webhook to push updates directly to the next.js backend, reducing API traffic. You replace coast asterisk with the exact production domain. Migrate to the production OIDC provider to strictly enforce ownership logic before signing JWT. Implement explicit entry logic for upload network and comprehensive error tracking to handle browser disconnections or network drops during multi-megabyte edge transfers. Thank you.